This lesson is on combined variation problems, where we're going to solve when there's more than just two variables. And we would also have directly related and inversely related, both occurring within the same problem. All right, we could still highlight if we chose to. The first part is going to help me write my generic equation, so I have to go to the steps. Like the note says, you must use the steps for solving. There are no shortcuts when it's combined variation. So step one, z varies. Since z varies come first, directly with x. So when it says directly with x, that part goes on top. Okay, so I'm going to have a bar, and x is going to go on top. It also says inversely with y. Okay, so inversely with y, that part goes on the bottom. Anytime it says inversely, it goes on the bottom. And then what we're looking for was going to find solve for constant k. Okay, step two. This is when we highlighted the pieces of information, the numbers that all seem to go work together. X is 6, Y is 2, and Z is 15. So what I'm going to do is take a minute to put all of these in place. So X would be a 6, 2 would be for Y, and 15 would go in for Z. So I'm going to have 15 is equal to 6 over 2, and we're still solving for constant K. Now, in looking at my problem, I have 6 divided by 2, which does reduce or divide to 3. So I have 3 times k is equal to 15. And if I divide by 3, my constant k works out to be 5. Now, step 3 is where you write the equation with constant k in it. So step 3, we still have z equals. Now I know that my constant is 5. It's going to be 5x over y. Now that I have that equation, I should be able to solve for anything that I'm asked, solving for an unknown. Find z when x is 4 and y is 10. So I'm going to substitute in find z. X is 4 and y turns out to be 10. So z equals 5 is my constant, my x is a 4, and then my y is a 10. So I'm multiplying the two numbers on top, dividing by 10, and I believe that's 20 divided by 10, which is 2. The final answer for number 1 is 2. I'm still following the steps. I just have a little bit more to have to concern myself with and keep track of. All right, number 2. Whatever I read first is what I start with first. So number 1, z varies. Z varies. Z equals. Directly with the square of x. So when I'm looking at this first part, that's what's going to help me write my equation. Directly with the square of x. That's x squared. Directly is on top. Inversely with y. This part goes on the bottom. It does not say squared or cubed, so I keep it like it is. And now I'm looking for constant k. All right, second sentence is going to tell me the pieces of information that goes together that I need to solve for constant k. So I'm going to put in to get z, looking for constant k. Z is going to be a 3. Z is a 3, so that's where the 3 comes from. 3 equals constant k. X, it says, is 2, so 2 is going to be squared. And then on the bottom, y is a 4. Okay, so this ends up resolving itself. 2 squared is 4, and then 4 divided by 4 turns out to be 1 because it cancels. So I end up with constant k simply equaling 3 because the 4 is divided out to 1. So constant k is 3. Now I'm going to write my equation and put in constant k in there. This is the third step. So z equals constant k, 3, 3x squared over y. That equation allows me to be able to solve for anything. Now, last part, find z when x is 4 and y is 6. So x is 4, so it's 4 squared. Y is 6. 6 goes on the bottom. Constant 3 is in front. And I'm looking for the answer for z equals. So I multiply it out and divide. That's going to be 3 times. Now make sure that you do your exponents before you multiply. So that's 3 times 16, because 4 squared is 16. So that's 3 times 16 over 6. 3 times 16 turns out to equal 48, and 48 divided by 6 is 8. The answer to the second problem is 8. Now that we've done some that are kind of generic with just X, Y, and Z, let's look at a couple of examples where we actually have word problems. Now, same kind of setup. I might have to choose along the way letters that make sense for my problem. All right, the time it takes to paint a fence. I'm going to simply use letter T for time. So T equals. Varies directly. So I know it says directly with the length of the fence. So I know the length of the fence is going to be something on top. And inversely with the number of painters. So I'm going to use the N for number. I do not yet know my constant K. All right. So it sounds like if there's longer and longer and longer fence, it's going to take more and more time to paint. If I use more and more painters, it's going to take less and less and less time. So this would be my original generic equation. Now I have to have some information, things that I know. 5 hours, 200 feet, 3 painters. Okay. 5 hours is a time number, so 5 goes in for time. All right. 200 feet of fence is the length of the fence. 200 would go on top, and it takes 3 painters. That's the number of painters, 3, so it goes on the bottom. And I'm still looking for constant K. Now, this is the one case where we end up having to solve. I need to consider this like K times 200 divided by 3. The opposite of divide by 3, I'm going to focus on the 3 first, is 2 times by 3. Remember, we're trying to get constant K all by itself. So if I times one side by 3, I do get rid of the 3, so I'm going to times the other side by 3. After that, it's also K times 200, because 200 dropped beside K means times. The opposite of times is divide by 200, so I'm going to divide by 200. Now the 200s cancel. Really and truly what I ended up doing is I ended up multiplying by the reciprocal, or flipping my fraction and multiplying the other side by that same flipped fraction. Okay, 3 times 5 is 15. 15 out of 200 is constant K, and I believe that turns out to be a very small constant, 0.075. All right, step number 3. The time it's going to take is 0.075 times the length of the fence divided by the number of painters. Okay, I put my constant in where it goes. Now, number 4. Now I'm going to use the equation to solve for something I don't know. So now I'm going to focus on how long will it take 5 painters, 500 feet of fence. The time it takes, 0.075 is my constant. The length of the fence is 500 feet, so 500 goes on top. The number of painters is changed to 5. Okay. When you multiply and divide, you get 7.5 hours. Number 4. Okay. It's the same thing as what we've done before, only we have a numerator and a denominator to have to make sure we simplify properly. The strength of a rectangular beam, okay, I'm going to use S for strength, varies jointly with width and the square of its depth. Notice that we did not see the word inversely at all within the first sentence. That means this particular problem will not have a denominator. Okay, so the strength varies jointly with the width, W would be my width, the square of its depth, depth squared. I still need to be sure I solve for constant K. Number 2, I should have all kinds of information that would let me solve for my constant. 3-inch beam by 10 inches wide, 1,200 pounds per square inch. I got to make sure I put the numbers in the right places. They're not written in the right order. 3 inches wide is the width, so I'm going to put a 3 right there for W. 10 inches deep. Now remember, square of the depth. So when it says 10 inches deep, that's actually the depth of 10 inches, and I have to square the depth. 1,200 pounds per square inch is a measure of the strength in terms of the pressure it can hold. So imagine a beam stretched across the room. There's a lot of pressure to hold up the structure. So that's what we're talking about. So that would be 1,200. Again, solving for constant K. So what I'm going to do is I'm going to go ahead and simplify these numbers. We're going to multiply 10 squared first. 10 squared is 100. 100 times 3 turns out to be 300. So I'm getting 300 times constant K is equal to 1200. All right, to get constant K by itself, I'm going to divide by 300. This one is easy. I can do it in my head. Cancel zeros. Constant K turns out to equal 4. So my equation with constant K in it says the strength of the beam is constant of 4 times the width times the depth squared. All right, and the last one, let's make sure we focus on what it is that we were asked to find. What is the strength of the beam? 4 inches wide, 6 inches deep. What is the strength of the beam? 4 is my constant. 4 inches wide is also my width. And 6 inches deep, 6, and I have to square the 6. All right, so when we multiply 4 times 4 times 6 squared, I believe we get 576. And it is described in pounds per square inch, which can be abbreviated as PSI. All right, so that would be how we would work our combination variation problems.